Welcome back learners, we are starting new chapter that is structure of the atom. In this chapter we will study more about atoms. Previously we have learned that atoms are the smallest particle of any matter which may or may not exist independently. So this is not all true. Atoms are not the smallest one. They can further divided into subatomic particles which are known as electron, proton and neutron. In today's class, students, we will find out how these subatomic particles were discovered and what are the various characteristics of these. So let's begin it. First of all, we will study about first subatomic particle, that is electron, and discovery of electron. The existence of electrons in an atom was shown by J.J. Thomson in year 1897. Students, Thomson did one experiment which is known as cathode ray experiment, and in this experiment cathode rays were discovered. Later on these rays were named as electron. So I will explain it to you. Let's zoom in and we will understand this experiment in detail. Now you can see one tube on your screen. This tube is cathode ray discharge tube. Okay, a glass tube taken by Thomson. In this tube, students, electricity at very high voltage was allowed to pass through the electrodes. Electrodes just pass electricity, and there are two types of electrodes. One is cathode and other is anode. Students, cathode is a negatively charged electrode while your anode is a positively charged electrode. You must know that. Inside this tube, gas was taken, any gas, and the pressure of gas was very low. At very low pressure, when a very high amount of electricity was passed through this discharge tube, so these gases got ionized, because of which they released electron, and as you know, electrons are negatively charged. They start traveling from this negative charge cathode toward the positive charge anode. So what Thomson noticed that he has coated this cathode ray tube with a photographic film of zinc sulfide. So when these rays travel inside this tube, a greenish light was noted, and just because of it, it was said that there is something which is traveling from cathode toward anode. As such, these rays were traveling in this direction. They got their name as cathode rays. It was found out that they are traveling in straight line. They do not depend on the nature of gas which is taken inside this tube. So it was said electrons are common to every atom. Okay, so this was the experiment done by Thomson. Now, as you have seen it, we can now say cathode ray consists of small negatively charged particles called electron, and all gases, they form cathode ray. Now we can conclude that all atoms contain negatively charged particle called electron. So now characteristics of electron. Students, two characteristics will be noted. First, mass of electron, and second, charge of electron. The mass of electron is about 1 by 1840 that of the mass of hydrogen atom. Okay, hydrogen is the lightest atom among all discovered elements. Since the mass of hydrogen atom is 1 U, you can say that the relative mass of one electron is 1 by 1840 U, and the absolute mass of electron in terms of gram, that is 9 into 10 to the power minus 28 gram. Now let's talk about the charge of electron. Students, the charge of electron is negative and the value is minus 1.6 into 10 to the power minus 19 coulomb. Minus to denote the negativity and 1.6 into 10 to the power minus 19 is the value, and coulomb is SI unit of charge. In terms of relativity, you can say the relative charge of electron is minus 1. Okay. Now this was the first subatomic particle which we have seen. The next one is proton. So students, just like the discovery of cathode ray, Canals ray were discovered using a perforated cathode and it was noticed that there are some rays which are traveling from anode toward cathode. Let's say this is our anode and here it is the cathode. The perforated cathode was used. It was having many tiny holes and some rays were discovered, they were traveling in this direction. So as they were traveling from positive toward negative, their nature was positively charged. They were called canal rays. Later on, they were given name of proton. Now, students, it was noted that the nature of these canal rays were depending on the nature of gases taken. Because when a gas got ionized, it released electron and a positive cation. Every gas will have different cation. That's why the nature of canal ray was different for every gas. Okay. Now we have seen that how the canal rays were discovered and how proton was does. The credit for discovery of proton goes to E. Goldstein. Let's see the characteristic. First of all, mass of proton. The proton is actually a hydrogen atom which has lost its electron. Now since the mass of this electron is very small, we can say that mass of proton is equal to mass of hydrogen atom. But mass of hydrogen atom is 1U. That's why the relative mass of proton is 1U. Students, you can say that your proton is 1840 times heavier than electron. Now next thing is charge. The charge of proton is equal and opposite to the charge of electron. So it must be in positive value and the number is 1.6 into 10 to the power minus 19 coulomb. The relative charge for a proton, that is plus 1. Now next thing, after the discovery of electron then proton, the next subatomic particle which was discovered, that was neutron. Students, when proton electron were discovered, it was noticed that all the mass of atom cannot be accounted on the basis of only protons and electron, just because the mass of electrons was nearly equal to 0. That can be ignored. So the atomic mass, let's take one example. Carbon is one atom that is having 6 electron and 6 proton. If you are ignoring the mass of electrons, then the mass of carbon should be equal to 6 just because it's having 6 protons. But instead of it, it's having mass 12U. So where does the extra 6 number came from? That's why another subatomic particle came to know, and that was neutron. This problem was solved by the discovery of another subatomic particle by James Chadwick in year 1932. This particle, as I told you, is called neutron and it's neutral in nature. It's having only mass. So hydrogen atom is not having any neutron just because hydrogen is having one electron and one proton. Now students, you have seen it. Let's see the characteristics shown by neutron. First of all, mass. As I told you, the mass of neutron and proton, they are almost same. So the relative mass of neutron is 1U. And what about charge? Charge of neutron is nothing. Neutron is having no charge. It's neutral. Now, here in this example, you can see atomic mass of carbon is equal to mass of 6 proton plus mass of 6 neutron. You know that mass of 1 proton is 1U and that of 1 neutron 1U. So it will give you 6U added to 6U and your answer going to be equal to 12U. Now we will compare these subatomic particles proton, neutron and electron. First of all, proton. Students, you know that proton was discovered by E. Goldstein. The symbol used to denote proton is P. Its relative mass is 1U, its relative charge is plus 1 and it is located inside the nucleus. Second is neutron, discovered by James Chadwick. Symbol is small n. relative mass 1u and relative charge is 0. It is also located inside the nucleus. Proton and neutron together known as nucleons just because they are inside the nucleus. Lastly, we have to discuss electron. The electron was discovered by J.J. Thomson. The symbol you use to represent it is E. Next thing, its relative mass is 1 by 1840 U. Relative charge is -1 and it is located outside the nucleus. So, in today's class, we have studied about these subatomic particles, their characteristics. In upcoming classes, we will study more about the structure of atom. That's all for today, students.